Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Hello all, welcome to episode 5 of Fire Code Tech. Today on our episode of Fire Code Tech is James Andy Lynch. Andy is a fire protection engineer with formal education from WPI in fire protection engineering. Andy's specialty is in fire testing and product development. Early on in his career, Andy worked for several different laboratories. He was part of a group who helped get a video detection system into NFPA 72 and get it listed with UL and FM. Today in the interview with Andy, we get into the research and development process. Andy explains what it looks like to commercially develop a product and get it listed through agencies like FM and UL. We talk about some of the unique projects that Andy gets involved with through his company, the Fire Solutions Group. I really enjoyed talking to Andy not only because he was a very knowledgeable fire protection engineer, but he also is an entrepreneur and had a lot of good insights for professionals. Don't forget to subscribe so you never miss an episode and follow us on social media. Let's dive in. Well, hello, Andy. How's it going today? Thanks for coming on the podcast.
It's going great. Thanks for having me.
Awesome. Yeah, I just wanted to get a little bit more about your background and how you got into fire protection.
Okay, well, I grew up in a town called Andover, Mass, which is about 20 or 30 minutes outside Boston, so you might hear a little bit of a Boston accent. I currently live in southern Pennsylvania, right on the Maryland line. How I got into fire protection was growing up, my father was a paid firefighter in the town. So I was kind of around fire my whole young adult life. I remember he'd get calls and if they needed extra men at a fire, I'd tag along and sit in the truck and watch. And they'd have the firefighter, the open houses. So you'd hang around all the trucks and people. And back then they had the poles you could slide down. I think most of the firehouses have gotten rid of those. So there was always kind of this knowledge and interest in fire and fire protection. Then as I progressed, I was at high school. I was a pretty decent football player, so I started to get recruited by some smaller colleges. I knew I wanted to do engineering. I was pretty good at math. I did well on my SATs in mathematics. My uncle was an engineer, actually worked on GPS systems, and now we're talking, this is 20, 30 years ago. So I knew I wanted to kind of build something, have something, and have that mechanical engineering background. Being recruited, I was recruited by RPI, Rensselaer Polytech, and WPI. Taking tours and looking at their curriculum, I realized that WPI had a fire protection engineering degree. And I think at the time it was WPI, University of Maryland, and Oklahoma had fire protection. So I decided they had a 5-year program. I was going to go into that 5-year program. I chose WPI, got an undergraduate in mechanical and a master's in fire protection. So I think, if I'm to pin it on one thing, it would probably be my father's influence to go into fire protection engineering.
That's a great story. I love hearing about that sort of stuff. Yeah, my grandfather was a fire chief and in the fire service as well, so that resonates with me and my experience with fire protection. So that's really cool. That's awesome that you were able to go to school and get a degree from one of the very few education programs that are out there for fire protection. I mean, even now there's not that many graduate programs or master's programs for fire protection. So I'm always really interested to talk to individuals who have degrees from those programs because there's not very many out there, and I'm sure they're all different but have some similarities. But yeah, I just wanted to get some more information about your education. Like, what classes did you enjoy in school? I know you said that you were good in math and sciences, Could you just go over a little bit of, like what classes you enjoyed in school, or maybe some of the how the fire protection courses worked when you went through WPI and what their degree program looked like?
Yeah, absolutely. So, and I think, going back on the call, I think the only other accredited program currently in the U.S. is Cal Poly. So it's, Cal Poly, Oklahoma, Maryland, and University of, I mean Maryland and WPI. As far as WPI, I really enjoyed my time there. One, it's a smaller school. I think there's about, well, when I went, I think it was about 2,000 students total. I mean, you have high schools that size now. And it's all engineering. Everybody there is kind of in the same boat. We're all stressed out. We're all, working hard in that engineering, the chemical and computer science and mechanical and civil. And so everybody kind of is well, like I said, in that same boat. Undergraduate, I enjoyed. I was playing football. I was in a fraternity. Had a good time. Got decent grades. I really enjoyed one aspect of WPI is they have a lot of hands-on opportunities. So your junior year, you have what's called an IQP, and your senior year, an MQP, and they take a semester and you just work on one big project in a group. So you usually have about a group of 3 or 4 kids working on some problem. And I actually got the opportunity to travel to Australia on both my
Wow.
IQP and MQP. So I lived in Melbourne, Australia, and I worked for a company called CSIRO, which is Commonwealth Scientific Industrial Research Organization. It's kind of like the NIST of Australia.
Hmm.
And my first project, my IQP, was actually on fire modeling. So I traveled around Australia interviewing people who were using fire models, what they were using it for, what features they liked. And it was kind of just more of like a data gathering for CSIRO to see what the industry was using and how they were using the fire models. My senior year, I went back and I worked for the same company, but I actually did temperature and heat flux mapping of an apparatus they use down there, which looks at wall coverings and carpets, and it moves it towards a heater in timed increments until you get things like ignition and flame spread. And they were trying to make it a ISO standard at the time, so they wanted to do the heat flux and temperature mapping, and that's what we did for that project. The other thing about WPI is you need to take a minor, and I minored in history, and you do a big project with that. So I actually wrote a paper on the Great Chicago Fire and the economic impacts of having a fire of that size on a city. So right from the start, because I knew I was doing fire protection engineering, even though I was getting a mechanical engineering degree, I focused on a lot of aspects of just fire protection and the history of fire. Then when I got into my graduate years, I really enjoyed the classes and the professors there. And, I actually ended up being a salamander, which is high honors in the program. I got to work in the fire lab at WPI. So there was a lot of opportunity to do some real hands-on fire testing, whether it was, abroad in Australia or in the fire lab there. And in addition, I actually got a job in the summers working for the Mass State Police doing fire investigations. So coming out of college, I had a pretty well-rounded background in fire, just from the testing, the investigation standpoint, design. So I think it really prepared me to move into, quote unquote, the real world.
Definitely had a well-rounded background by the time you got out of college. That's a diverse set of experiences, and none of that is even in your, your formal listings for, before you got out of college. You had all this experience in, and I think it's really interesting that from an early part in your career, you had an interest in testing and fire science and really getting into the modeling and that sort of thing, which I feel like, in my opinion, fire protection is just such a young industry and, just like budding and around the 2000s, it seems like it was picking up speed and like people starting to really take it seriously and becoming its own thing. So I think it's just super interesting that you were getting involved with fire testing and doing cool projects like traveling to Australia. But yeah, that's awesome. I wanted to touch on a couple of things that you talked about. I really liked you talking about the historic fires. Something that I would imagine that a lot of fire protection programs do, since a lot of code or standard is written by disaster, unfortunately. So I thought that was great. And yeah, I think that from early age, I can kind of see why your career went in the direction it did, since like in college you were already getting into the research and fire science, the heavy fire science and modeling. So yeah, I just think that's interesting from knowing you from afar. Next, I just wanted to get in more of your professional career and talk about a high level overview of your professional career and yeah, just a little bit of history about your working career, if you don't mind.
No, not at all. So when I was finishing up WPI, although I had gone in a 5-year program, which is supposed to accelerate it, and the only issue I had with that is, like you said, I knew I wanted to do fire testing. I figured that's, going back to the reason I got into engineering is I wanted to contribute. I wanted to build something, have something that I could say, this is what I'm contributing as far as something physical. So I kind of knew I wanted to do more testing rather than design work, and more just creating paper reports and design drawings. So if you're in that 5-year program, you're not allowed to do a thesis because that obviously takes about a year's time, or do an internship. So at the end of my WPI career, I actually decided I was going to do a master's thesis, and I wanted to do an internship just to get some work experience. So I actually got hired by a company called Combustion Science and Engineering down in Columbia, Maryland. So I moved down, and they actually funded my thesis work, where I actually used laser scattering to size soot particles over time. So we would burn small samples of different materials, and then we would actually shoot a laser through it and gather the scattering. And the scattering, based on the particle size, changes. So you can actually monitor, growth of soot agglomeration. And the whole point of it was, we know that smaller particles make ion detectors activate quicker, larger particles make photoelectric detectors. So it was trying to look at the aging process and changes in particle size to then relate it back to smoke detector activation for litigation cases. So that was kind of my first job, was at CSE and finishing that thesis. I also took one class at University of Maryland to actually finish my degree, which was a toxicology class that Maurer, Milky, and Purser. So Purser wrote the section on toxicology in the SFPE handbook, and then most people listening to this will know Maurer and Milky. Maurer now heads the program at Cal Poly, and Milky's the
Hmm.
head of the University of Maryland program. So it was a great class to take because
Wow.
I got to meet those 3 individuals. But going back, so Combustion Science and Engineering was my first job. They have a fire lab in their facility. They did a lot of litigation work at the time. So we were doing a lot of fire testing. Like I said, that sizing of soot particles. We also looked at deposition of soot on smoke detector horns. So you can actually tell if a smoke detector activated or not based on the soot deposition, which was a really interesting project. From there, when I finished my master's degree, I actually looked around for other opportunities and went to Hughes Associates, which is now Jensen Hughes. And at the time, they
Hmm.
were about 150 engineers, but they were a great company to work for. They were in the Baltimore area as well. They had a fire lab in the back, so I got to work in that fire lab. I worked on some litigation cases, did some smoke control. I was a young engineer, so I tried to grab as many projects as I could. And then the big projects I worked on there were actually for the Navy, the Naval Research Labs. I think to this day, Hughes still has the contract with them, and they have a ship down in Alabama that we did a lot of fire testing on, which was a great opportunity. I was there and I was working on, now this is, you're talking about 15 years ago. We were working on the detection suppression systems for the next generation of destroyer and carrier. And we were looking at
Wow.
video image detection. We were looking at UV, IR. We were actually looking at acoustic detection. So we had microphones in the compartments, and we could hear if there was a pipe rupture or some event going on. And then what happened was one of the startup companies that was doing video detection at the time actually hired me away from Hughes. And I worked for a company called Exxon X. I was actually the third person. I was a partner in that company. And we developed video image detection from what it would do was take normal CCTV cameras and feed them through a server and process the pixels to look for fire and smoke. We ended up building a fire lab, doing a lot of comparative testing with other detection, air aspiration, spot type, heat type, and looked at how video detection would perform. We migrated the analytics from the server actually on board the camera. So you had a self-contained detection device that had dry contacts that could feed into a fire alarm panel. And then we actually got that technology FM and UL listed, and there was no listings at the time, so we had to actually work through the process with FM and UL to create a new standard for video image detection, um, and then test to it so we could get the UL and FM mark. And then we also got it into NFPA code, NFPA 72, adopted video image detection, as well as, we were finding customers and doing beta test sites and rolling out the product. We built it up to a point where Fike, which is a fire protection manufacturer, bought the company. I stayed on board with Fike for about 3 years, and that's when I left and started the Fire Solutions Group, which is where I am now, and I do mostly fire testing.
That's an amazing career you've had so far and continue of having. Man, that's really impressive. I really enjoyed hearing about specialization in detection and research and testing. It seems like is the through line in your career. That's really interesting stuff. Just wanted to hear a little bit more about what does it look like. You're speaking about some of these research processes, and I have this image of what that looks like in my mind, but I've never had the opportunity to speak with somebody who does this for a living. When you're talking about testing certain detectors for litigation purposes, what does this look like? What are you doing on daily basis to perform this kind of work?
Yeah, so it's probably less fire testing than you'd imagine. Although 90% of my business is fire testing, being the owner of your own company, you wear a lot of hats, and so there's a lot of emails and marketing. I mean, my typical day, I do have a wife and kids. I wake up at 6 a.m., have a big cup of coffee, and get them off to school. I have an office in York, but sometimes I work out of my house. But a lot of it is writing proposals, talking with clients. You can kind of split my clients into two categories. One is the small startup company or a smaller company, and they're typically trying to get a technology into the fire protection market. And some of them
Mm,
have been in the fire industry, some of them haven't, and it's explaining that process and understanding the dynamics of, it's not like you put this on a shelf and sell it at Walmart. I mean, there's a lot of moving pieces
right.
between the AHJ, the building owner, the insurance company, you know, NFPA codes, FM and UL consultants, and how you actually go to a market with a new technology. So I try to help with them with that. I speak to them about the process of how to get things FM and UL listed. I do a lot of code review and tell them, where they would fit in the code, if anything addresses their technology. In some cases, it doesn't. So I'm writing text for NFPA codes to, get the committee to adopt it, so that they can then point to the code. I'll help them through FM and UL. So whether it's developing a new standard to test to, or finding the right standard. And then, there is a certain portion of my work that is, I I write a proposal, and I run a test series. And I have a number of places that I test at. I've tested at University of Maryland. I have Intertech right up the road from me, probably about 5 miles from my house. So I've tested in their fire lab. I have access to the fire academy here, Aberdeen Proving Grounds, WPI, FM, UL. So depending on what the test is, I find the appropriate, facility to test in. I'll write up the report, and that will be the deliverable. As well as I always like to either write a paper or present on the material that I've tested. So recently I was down in Atlanta for their SFP Atlanta chapter expo and conference,
Hmm.
and actually gave two talks. One was on some testing I did over the summer with wetting agents, and another is on an augmented reality tool I'm working on. So it's really important not just to do the testing, but actually roll it out and get it out so that people understand what you did, and no one else is kind of repeating your work unless it's for verification purposes, but that it's not redundantly done. And it's important for people to know that information.
I think, like most things, the perception of what something is and what it actually is a lot different. And so I think that's interesting for you to talk about. The nitty gritty of it is documentation and writing proposals and finding the appropriate tests and writing a test plan and then presenting it and publishing your work and moving through all those motions. So yeah, I always like to get the real story because usually pretty different than how you would imagine. You think of people in these lab coats, doing these dramatic experiments, but it's the reality of it is a lot more of writing papers and documentation and crossing your T's and dotting your I's as far as getting into the codes and standards. Yeah, I think that was a really interesting point you touched on with how fire protection is not just a field where you could put something on the shelf and just have it go to market. I've talked with a couple different companies recently, one for a wetting agent, one for an alternative to AFFF, and just a couple different companies. And just it seems like there's such a barrier to entry to the fire protection industry. If you're not listed or you're not in the codes and standards, most fire protection professionals just don't want to give you the time of day. So
Yeah, and that's it's too bad because there is a lot of good products out there, and I try to help the smaller company. I mean, that's was the mission statement of the Fire Solutions Group, was to bring technologies into the fire protection market. And so I see a lot of companies, and they're burning through a lot of money in on the sales side, and they don't have testing to back up their product. They don't have FM or UL. And I mean,
mhm.
if you don't have FM and UL, you at least need to have some testing verification so that you can at least write a variance and say, this is why we're equivalent. And it's kind of trying to explain that to them and say, look, I think you have something good here, but you need the documentation. You need some third party to test it and say, this does what it says it's going to do.
Yeah, that's an important note as well. If you don't have the testing and you don't have some sort of documentation to go to an AHJ and say, this is why it's equivalent, you're going to have a really hard time getting that product into a lot of the larger marketplaces. Sure, you might be able to get it passed in some smaller jurisdictions or some less heavily regulated jurisdictions, but if you want to get into the big marketplaces, you're going to have a really hard time if you can't explain to an AHJ with some data to say why this is equivalent.
Right.
So that's awesome. You talked a couple times about UL and listings and FM approval. Just wanted to hear a little bit more about what it looks like to get a product UL listed or FM approved. What is it? How do you start that process? I hear is something that can be very expensive and very time consuming to do. So
Yeah, it can be. So, the big three in North America and the US is you've got Factory Mutual, you've got Underwriter Lab, and then you have Intertech. So you've got the FM Mark UL listing, and you've got the ETL, which is Intertech's mark there. So it really depends on if you have a product that already has a standard, or if a lot of the companies I work with have a very new and unique technology. So you kind of have to either find the standard that closest fits, or you have to talk to FM about creating a new standard, test standard. The reason we have these companies to start is that when we look at the life safety industry, we want to make sure things work. We want to make sure that we're getting the same piece of equipment every time we purchase it, that changes aren't being made that could you know change the functionality of it, and it's for consistency. So The testing portion of it, the fire performance test is just one piece of it. Most of uh, these processes to get a listing is actually a lot of component testing. So they want to see what failure rates of certain rubbers and plastic gaskets are. They want to, make sure that the functionality of some valve or some circuit board. I mean, there's one test where it's just turning a device on and off 500 times. There's a lot of just wear and tear, corrosion, electric tests, that just to make sure that the device that's going out in the field is going to be resilient. So and then you've got temperature tests where they bring stuff down to -40 or zero, and up to 100, 120, whatever the high temperature is. So a lot of it is component testing. You have the fire testing, and the next part is looking at the manuals, looking at your spec sheets, anything you're going to put FM on. They want to have control of that to make sure you're not saying something that's outside the listing. You're not making a claim that isn't true. And so it's protecting the market. It's a life safety device. So they want to make sure that that's going to function. And then with FM, there's follow-ups on the manufacturing facilities. They actually come out and do quarterly audits in some cases where every quarter an individual from FM comes into the facility and makes sure that your manufacturing process, your quality control in the manufacturing process is there. So when you get a product to submit it, you go to FM, their website, they kind of break it down by different departments, and you'll send in drawings, you'll send in your manual, you'll send in, there's paperwork attached. I do an authorized agent form for my clients so that I can speak directly to FM on their behalf, and then they'll give back a quote. If there's a standard that already exists, the quote's pretty cookie cutter. They say this is how much it's going to cost, depending on what device. I mean, yeah, it can take up to a year. I know that with any kind of pressurized cylinder, they have a year-long leakage test. So you're going to start that right away, and then you'll start doing all the other component tests in the meantime. So a year is a typical time frame. It could be shorter if it's a simple spray head, open, deluge spray head. It could be 3 months. Prices range from $3,000 to I've heard tests, for ESFR sprinklers, they're actually going to do full rack tests. So you're going to
Wow.
it's going to be very expensive to run those. I've heard tests as high as or close to $1 million to get a listing
Wow.
on some devices. If there isn't a standard, then it's a lot more difficult. Now you're talking about a 2, maybe even 3 year time frame where you're presenting the technology, you're presenting the case on it. Someone has to kind of be your champion at one of those organizations and say, yeah, we can see why this would be, benefit the industry. Or in FM's case, I mean, the reason FM's approving is for their insurance clients. So they want to make sure that there's a reason that their clients would be putting that device in. So if you do find that champion, then what they're going to do is say, okay, we'll form a committee and we'll write a test standard, and they'll usually give you a cost associated with that. When that cost, if you pay that cost and they move forward and they build that standard, then you pay to actually test to that standard. So you kind of hit double hard on that aspect if there isn't a standard already.
That sounds like quite an uphill battle. Yeah, you touched on something really good here, though, is I think you answered a question that was I kind of intuitively understand, but you went into some different parts of it is why do we have these listings? And it's for good reason that we have these listings for life safety products but yeah, you also dove into some of the more uncommon pieces like component testing and resiliency and temperature testing. And so those are some things that I didn't know about and some of the interesting parts of this process. But yeah, I find that's really great to hear about and something that I was not that aware of, but that's pretty neat, pretty incredible that it could be anywhere from 3 months to 3 years. So that's the range, as it sounds like. And yeah, getting a committee formed just for the release of a project sounds like something that is not easy to do, especially if this isn't something that you're in the business of, is, these kind of endeavors.
Yeah, and for a small startup company, it's difficult. I mean, it's something where you almost have to have early adopters and people who are using the technology just to fund and get it through. I mean, there has to be a pretty strong demand for the product to be able to last that time frame and get a product out to market with an FMUL or ETL mark on it.
It's cool that you get to work with small businesses and help these people who I've seen some really neat products. And even if you have a product that works extremely well for a certain industry or people using it, and there's clear that it's has a great benefit, it's still a very hard process to get these things listed. So I think that's incredible. Next, I just was thinking you spoke a little bit about your project work and your different design work. I just wanted to dive a little bit more into your project work now at Fire Solutions Group and just get a little bit more about what you're doing now. I know you've told us that predominantly you're doing testing and some of that kind of work, but yeah, I didn't know if you could expand upon that a little bit.
So, when you look at my two customers, I kind of hit upon the smaller company side. The other half of that is I work for larger companies as well. You know, a lot of utility power companies, manufacturing, pharmaceutical stuff, usually with higher hazard. Oil and gas would be another big one. But they come to me and they usually want me to test a product that they've been approached to see if it actually functions the way they are claiming, or if they're using it in a unique application, is it going to function the way they intended? So some of my projects, that one I recently worked on was actually a thermally activated gas shutoff. And so they wanted to look at when it would actually engage, when it would shut the gas supply off under different heat fluxes, as well as different flow rates of gas. And so we actually found out that, yeah, the flow of gas does affect the activation time of the device because it's actually cooling it as the gas passes through. So that was kind of an interesting project. And the smaller ones, I've worked very closely with International Fog, and we helped them develop a new nozzle. It's an open head nozzle that actually has a rotor on it. So a lot of firefighters refer to it as a cellar nozzle or a Breslin distributor nozzle, but it has fine holes. And what's great about that nozzle is we tested it in a piece of equipment called the 4S, and we found that at the same flow and pressure as a typical deflector plate sprinkler, we actually get better distribution of water and we get further throw. And it's because you're not losing the momentum of the droplet by hitting it against a plate. The spinning rotor actually shoots the water out at a further distance, so you could actually get better spacing with that nozzle and cover more. So that was a pretty interesting project. Of course,
Hmm.
the vid from the last company was a very long and interesting project as far as bringing that through FMUL. I work with a lot of agents, both foam and wetting agents, testing those for different applications. Lithium ion is big right now, so I've been doing a number of those tests in addition to your typical, pan fires and wood crib fires. I'm working with a company that's doing some nano mist. So it's actually, if you look at your water mist range, it's up to 1,000 nanometers. The nano mist is actually single digits, so it's a very fine droplet. It's more of a fog. Also working on some battery safety systems to try to reduce the amount of flammable and HF gas coming off lithium ion on batteries. So those are some of the technologies and projects I'm working on currently.
Very interesting. Yeah, I like. I have a huge personal interest in suppression, and so I like hearing about people making basically being able to distribute less water farther or get better coverage with your nozzle that you were talking about. That's something I find really interesting. I have a huge personal interest in. Just recently was looking at a job and was looking at the sprinkler heads and how far they're spaced, and I was like, I don't think that I know of a sprinkler head that has a 32-foot spacing, and so this sprinkler head is either underspaced, or I need to take a look at the identification number and get it figured out. Yeah, it's always interesting working with existing construction, but I like hearing about those new technologies. That's cool stuff. You talked a lot about some different testings and some different products you've been working on. Yeah, I saw some examples of some modeling and some simulation software on your website. What kind of simulation programs, or do you guys use FDS or some of those type of programs, or
Yeah, so I get asked, or in a test series, sometimes I'll do a little bit of modeling for my own, kind of self interest to see where the fire is going to go before I run a test. If it's for a client, I've learned enough about fire modeling, and it's something I don't do on a consistent basis that I've learned to outsource. And what I mean is, you got to be really careful with fire models and who's running them, what their qualifications are. If they're not doing it full time and haven't been doing it for a number of years, you really got to worry about what inputs and outputs are coming in, garbage in, garbage out. And if they don't have a good process, chances are you're not going to get the results that you're looking for, what is actually going to happen. So there's a handful of people that I know have been doing. I mean, one of them's Noah Ryder, from the Fire Risk Alliance, which is a sister company of mine. A good friend runs it. Terry Fay is another one that I would trust running fire modeling for me. So a lot of times I'll contact them, and they'll do it for me, and obviously it's for my clients. So they kind of give me the results, and I'll write up the report. It'll be part of a larger project. But yeah, there's you got to find a really good fire modeler, and usually it's someone who does it on a day-to-day basis, and has that experience and understands the model and all the assumptions, and so that's what I do.
that's my perception of fire modeling as well, that it sounds like it could has a very steep learning curve, and you got to know what you're doing. And I talked with somebody recently who specializes in performance-based design and like FDS simulations and all that, and they had some different ideas about it, but I think they do it for a living. But it seems very not intuitive and complicated to get into, so that's why I wanted to ask the question. But yeah, that makes sense. If you don't know, I learned that garbage in, garbage out when I was first starting to do hydraulic calculations early on. Sure, you can get your water supply to work if you're not putting in anything that's real or has any basis in reality. So I could see how you could very easily get into that same scenario with simulations and modeling. So I've seen from taking a look at your website and your LinkedIn that Fire Solutions Group also has like a emergency response, or like an active firefighting portion of the business. Yeah, what is that? What kind of clients do you guys interact with on that basis? Or I don't really understand like the services are there. So you guys are like emergency responders to high industrial facilities.
Born out of necessity. We work with a lot of power companies, and there was an instance, and I'm trained as an industrial firefighter. I go down to Teaks on a regular basis, and go through their industrial fire school. But this was actually a case where actually our first one was a large coal bunker, and they had a fire, and the local departments had been fighting the fire for about a month. And all the fires we do that we respond to are bulk
Wow.
material fires. So not flammable liquids, but you're talking about large silos that could have coal in it, or corn feed, or we've done pecan shells. There's just sawdust. It's those type of fires, and what's unique about those is they're very slow. They're deep seated fires. So something happens, either a hot material, or it can even be, self combustion, or there's like a growth of mold that's producing heat. And the heat's trapped in this bulk material. So it heats up high enough that an actually smoldering fire begins. And the fire will kind of spread in veins and form crust in the material as it burns and kind of follows the oxygen. But these can be burning for weeks, months at a time. Like if you're in a silo, there's been cases where the fire's been going for a month and it's just a real slow burning, progressing fire. What's dangerous about these fires is you have, a risk for a dust explosion, and you can have CO build up, and the CO can build up in the headspace of the silo, and then if a spark happens, you'll get the explosion. The top of the silo will blow off, and the only way to put these fires out is you have to empty all the material from the bunker or from the silo, and then once you get all the material out, that hot spot's out, and the fire is done. So there's kind of a process where you wet down the material, and then you start slowly unloading. And that's why the fire department couldn't get the fire in the bunker out, is because they never started to unload the material. So when we got there, you usually spend a day or two just soaking down the material and letting the water. We use wetting agents, F500, and we use a new one, Crossfire RX, because it breaks the surface tension of the water and can actually migrate through the material. And I just did a presentation on that at SFPE in Atlanta. But once all the material's wet, then you can start the unloading process and empty it out. So, again, you hear emergency response and you think about a fire truck getting to a house fire in 5 minutes. This isn't that. We get a call and we're usually there within 24 hours, but we could be on site for a week putting this fire out, if not longer.
When I heard wetting agents earlier, I was immediately thinking of like firefighters, or I had seen a presentation recently comparing wetting agents to foam and showing how effective they are. I think that's interesting that your company actually gets into the functional use of those wetting agents. And yeah, for those who don't know about wetting agents, what are wetting agents? From my understanding, it just makes water, it's like an amplifier effect for water. It just makes the water adhere better. But yeah, what are wetting agents?
It's really interesting because if you go to the NFPA code, so NFPA 18 and 18A is it kind of covers the category of wetting agents. And if you read, and I would suggest everybody do this when they go to a fire code, read the history of it, because some of them are very interesting. On that first cover page, I think it's maybe right after they list all the committee members, they tell you a history that runs through what the code is about. So when you read NFPA 18, what's interesting is, and a lot of people don't know this, is foams was originally a wetting agent. The whole foam NFPA 11 category came out from NFPA 18. So 18 is actually the original code that foam was in. Just foam became so widespread and used that they split it out and created their own code. But a wetting agent is pretty much any additive to water. And probably one of the issues I have with the wetting agent code right now is that it's all encompassing. So I know products, and I work with products that actually thicken the water and make it into a gel, and they would fall in that category. And those are good for like thermal protection. I've started to play with the idea of actually spraying it on adjacent tanks, that if you have like a full surface tank fire, will you actually be able to use less cooling water by using a gel, or like a LPG sphere? Could you use a gel to keep it cool versus, the water method? But I know it's been used in forest fires and applications like that. And actually for Class C manhole fires and pole fires, they use gelling agents. On the opposite side is you get a lot of agents that break the surface tension, which is good for bulk storage fires. And I just showed cotton, which is really hydrophobic to water. It can penetrate into the cotton and put out a fire, which is a pretty difficult fire to suppress. So you have that surface tension, and then you have a category, encapsulating agents. And what those do is when they mix with the flammable liquid, they actually make the flammable liquid inert. So it's good if you just have a pool that's not on fire yet, you could spray it and inert the flammable liquid, but as well as putting it on Class B fires. I wouldn't say necessarily a pool fire, but like a three-dimensional fire. Those encapsulating agents are really good at. So if you have a diesel engine or a transformer or something like that, it would be good for protection. And I've seen those encapsulator agents used in fixed systems for those transformers and diesel engines, as well as for manual operations. So that's kind of the When I say wetting agents, it pretty much covers every
Hmm.
water additive that's used for firefighting outside of foam, which split off from the wetting agent category, and made their own fire code.
I was aware of, an encapsulating agent, but I don't think that I knew that it was more nuanced than that. And I think that's interesting what you're saying about, it's any additive. So there's, different subcategories of the effects and the firefighting properties of these different types of wetting agents. So that's really interesting. I like hearing about that. Yeah, I feel like maybe once these encapsulating agents get more tested and maybe we have some time that they might be, from the one that I heard a presentation on, it had a really minimal environmental impact. And as far as effectiveness, it was pretty comparable to foam. And so, yeah, there's been quite a shakeup recently with foam and hanger firefighting, or hanger fire suppression, I should say. And so I think it's be interesting to see where
Excellent.
the industry goes with that sort of thing. Sort of on the same path of emerging technologies, or where the industry is heading. I saw that Fire Solutions Group has a product called Fire Vision, or it looks like it's an application or something that you guys are working on. It works with augmented reality. Tell me a little bit about that.
Yeah, sure. So it's something I've been working on for since actually last April is when I started the process, and it's the first in-house new technology development that we're doing. Usually I work with clients that have come up with an idea. Being kind of involved with new technologies, I always look at anything that's coming out that's not in the fire industry and go, okay, could I apply this to the fire industry in some way? And so I started looking at virtual reality and augmented reality. Virtual reality being, you put on a set of goggles and you're completely immersed in a digital world. And I think that's good for training exercises, almost like a at the command post type exercise or size up. When you look at augmented reality and you start digging into it, it's pretty fascinating because it's not just, the definition is it's a digital image that you is visually overlaid onto a real live image. So you think of like the NFL does the first down line in yellow. That's augmented reality. It's not actually there. They're taking a digital image and showing you information that you would otherwise have to think about and say, okay, it's 2nd and 5. They have to get 5 yards, and here's the first down line. It's so much more than that, though, because when you look at the implementation of it, it's really a new way of organizing the world's information. So when you think of what Google did for the internet, where you can just type in and search and you get that information is now going to be distributed globally to where it makes sense. So if you're visiting a historic site like Gettysburg, you could hold up your phone and get information. You could see, Abraham Lincoln giving the Gettysburg Address or Pickett's charge up the hill at Gettysburg. But in the fire industry, and what I would like to do is, I walk on a lot of sites like an oil and gas terminal, and it's like, okay, well, where's the fire pump? Well, wouldn't it be great if I could just hold up my phone and I have the icon for a fire pump and it shows me right where it is? And then when I walk up to that, I push that icon and it gives me the manual or gives me the inspection, testing, and maintenance forms, or it gives me, it's the pump curve, all this information that we gather during a fire hazard analysis, and that the building owner is interested in. The fire department wants to know where the FDC connections are, and how much foam do I need for a full surface tank fire? How much cooling water am I supposed to be getting on the adjacent tanks? Everything that's in their emergency response, would be there at a glance, and you'd be able to see it. And so we're in the process now of implementing that. I've been having a team of developers work on it. And part of it is you 3D map an area. There's a large push by a lot of large companies. You're talking Apple, Samsung, Facebook. All these people are getting into the augmented reality because they realize this is kind of the next big thing. And there's actually whole cities that have been 3D mapped. All of London is. New York City will be this year. There's 100 major cities. There's also the technology out there to do it. So I just bought a camera. It's called Matterport, and it's sits on a tripod and just rotates in a circle and takes a 3D map of indoor and outdoor locations. You take that 3D map and change it into what's called a point source cloud. And what that enables you to do is put these digital images in a spot, because GPS isn't good enough. There's too much drift. But when you 3D map, it's going to stick that icon, that image where it's supposed to be. So we're using all standardized hazmat icons, as well as NFPA 170 is the standard for images and icons that are used on floor plans or your design drawings. So we're using a combination of those icons along with some other ones, and then attached to those, depending on what the icon is, will be the information. So if it's a hazardous material, you could have, as well as inspection data, but you could have the MSDS sheet there. And so that information will be stored on the cloud. So now when I walk into that same fictional oil and gas terminal and hold up my phone, I know where all of my fire protection hazards and resources are, and I have information on those about what condition they're in, when they were last inspected. And I think that's going to be a really powerful tool for the fire industry as a whole to organize the information, but communicate the information to each other between HJs, insurance, building owners, firefighters, consultants, and the contractors that are responsible for constructing and doing the inspection, testing, and maintenance of the equipment and hazards.
That's really powerful. I guess I could tell the, appeal from a emergency response side of things, but yeah, what really piques my interest is when you're talking about, integrating this technology with building information systems. And, that's what I do as a job every day is, 3D modeling and integrating data into the way that, we construct and, develop contract documents. I could see, this program. I love what you're saying about walking up to a fire pump and being able to, get the capacity and the rating and the pump curve and then, the ITM data, inspection, testing, maintenance data. That would be so beneficial because all that stuff is usually pretty hard to find, in an existing pump room. It's almost impossible unless the rating plate is on there.
Just saying, and that information is usually scattered. I mean, you have to go around to multiple parties. If I want to see the emergency response plan, I have to talk to the fire department. If I want to see, the design drawings, I'm talking to the consultant. If I want to see the as-built, sometimes it's the contractor. And, I'm lucky if the building owner has, a lot of this information readily available. So that's why it will really help up and speed up the process for everybody.
Yeah, definitely. I can see just a lot of benefits to that idea. It's like take a look at a building from the outside, and could just be able to say, oh, this building is sprinklered. This building does not have a fire pump, like the FDC is located here, there's these other fire protection systems in the building. And as far as streamlining and testing and inspection stuff, I think that'd be wonderful. But yeah, I think that has a lot of promise, and yeah, that's neat to hear about. I get excited when I hear stuff like that because I think that fire protection is on the crest of about to seeing a lot of these technological advances impact the field. And yeah, it's exciting to see where things are going. Yeah, I wanted to move on to maybe one or two questions about professional development, since it's clear to me that you've had an amazing career in fire protection so far, and you get to work in some really neat fields. So, and I love what you said about looking at the history and the NFPA standards. I definitely have looked at those before, but I just kind of glance over them and think, oh, this is just some rhetoric by NFPA. But yours, I love your tip about go take a look at those because they actually have some really interesting information. I haven't heard that before, but I really like that. Wanted to ask, Yeah, what fire protection resources would you recommend to professionals?
Yeah, I mean, if you're not, I mean, already a member, you should definitely become members of NFPA and SFPE. Try to attend your local SFPE meetings. I try to go and speak at as many as I can every year. I'll try to give, like I said, part of testing is distributing that information and making sure people are aware of the tests that you've done and what you've found out, so it can help them design and install better fire protection systems. So yeah, I would say go to those SFPE meetings, become an NFPA member. My most productive week, business wise, is NFPA Expo. This year it's down in Orlando. Next year it's back in Vegas. I mean, hopefully, if this coronavirus pandemic ends, they won't delay it. But I mean, even if your
Yeah.
company isn't going to pay for it, or I mean, I've gone every year to NFPA, and some years I've had been in a booth, some years I've done talks, and even if I don't do those two things, if it's just walk the expo floor, it's worth going because of the people you meet. You can get insights into what's going on in the fire industry, what some of their issues are. I personally like those outer aisles because those are usually the startup and potential clients for myself, people who are just getting into the fire industry and they have a new technology and they're trying to get it into the industry. So I like talking to those outer booths, as well as the big guys, the Honeywells, the Siemens, the JCI Tyco booths, and going in and seeing those guys and making connections and
Mhm.
going to the events. A lot of the big companies have open events after the conference closes, where you can kind of mingle and you know find people, find a mentor. If you're young in the industry, find someone who you want to do what they do, or learn about what they do, and get a mentor. And then LinkedIn is a great resource. I mean, this community is a small community. I mean, there's 4 colleges in the US, and when you're talking about people with FPE degrees, it's not 7 degrees of separation, it's two. So we're a small community. You can really learn everybody who's kind of in the
Yeah.
industry, and connect with them in some form or fashion. And it's those are probably the big three, is just the networking and mentorship aspect of the industry.
I think that's all good advice. Yeah, I haven't been gotten the chance to go to NFPA yet, but I really want to get there. But it sounds like just a great place to meet people and all of the resources and talks, and as far as the who's who of fire protection and what's going on in the industry, it sounds like that's probably the biggest event for definitely in the U.S. Just had one more question, and we can wrap this up. What do you wish you would have known before you started in the FP field? I know you just gave a lot of great advice for young professionals, and that might have encapsulated all of your thoughts on that sort of thing. But yeah, I didn't know if you had anything, any culture shock or anything that you weren't aware of before getting into fire protection. Sounds like you had a lot of experience with it from a young age, so maybe not.
Yeah, one thing, if you're still in college, or maybe you're listening to this and you're going to go into an FPE program, it would be take full advantage of being in college. I mean, there's a lot of resources that when I look back, I'm like, man, I wish I, spent more time in the lab. I had great professors at WPI. I wish I, kind of pick their brain more, talk to them more. I mean, and it's all free, right? I mean, you've got free access to a fire lab. You have free access to this knowledge base, and probably taken more advantage of that aspect. And then the other thing I'd say is try to decide where you want your career to go early on. And whether I knew I wanted to do testing. I mean, right from college, when I started running tests, I enjoyed it. I knew I wanted to do fire testing, and I took a career path that was that way. But whether you want to, if you want to do smoke control or detector, or I mean, try a bunch of different things, learn about bunch of different things. But do you want to be a design engineer your whole career, or do you want to be a project manager? Do you want to own your own company? Do you want to transition into a business role rather than doing whatever your goal is at the end of your career, or NFPA committee member or whatever it is, try to plot a path to that and pick companies that are going to help you get there, pick mentors that are going to help you get there. And that would be my advice, is kind of plot out. And you may not get that company that, the job at the company that you wanted, but even if not, I mean, you can pick a mentor that's outside of your company and start talking to them and get insight from them. People in the industry are I've found relatively easy to talk to and will share information if it's going to help, another fire protection professional.
And I think that, like you stated previously, fire protection is so tight knit that people are really they want to help you. They want to see you do well. They want the industry to do well. So yeah, I think that's all great advice. Well, Andy, thank you so much for getting on and talking with me. I know I learned a lot. Thank you so much.
Yeah, no problem. We'll have to do it again.
We should. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.